Alright, what's up guys? In this video we're going to play with some calculus here, and we're going to be talking about how to find the radius of convergence. So we're just given this series here from k is equal to 0 to infinity. We got x minus 1 all raised to the k all over k factorial. And he wants to find the radius of convergence. Okay. So remember that the radius of the convergence is really just half of the interval of convergence. And typically when you're finding the radius of convergence, they may ask you to find the interval of convergence, which is basically a set of values for which the given series, whatever series it is converging by basically a minus r less than x, or x is less than r plus a. And basically what you do is you use the ratio test. And if you don't know how to use the ratio test, I have videos on how you use the ratio test just in general to check for convergence of a series. So go back and check that out, because you need to know how to do that if you want to do radius convergence, because that's the test that we are going to use here. There are some cases where you can use the root test, but 9 times out of 10 you're going to be using the ratio test. So all we got to do is use the ratio test here, and we'll see what happens. So let's go ahead and use our ratio test. And let me just again remind you of what the ratio test tells us. So for the ratio test, it just says that L is going to be equal to the limit as n goes to infinity. It's going to be the absolute value of a sub n plus 1, all divided by a sub n. And remember, for the ratio test, if L happens to be less than 1, then the series converges absolutely. I'll put ABS for absolutely. If the limit happens to be greater than 1, or let's say we get infinity, then it diverges. And remember, if we get L is equal to 1, it's inconclusive. Or test is inconclusive. So let's go ahead and use that ratio test here. So we got the limit as k goes to, in our case, we'll use k, since that's what we're given. And by the way, in the formula, keep in mind, some books use n, some books use k. It doesn't make a difference which one they use. So if you're given a problem that's using k, and maybe you're used to using n, just modify it a little bit and just use k. Some books use k, a sub k, some books use a sub n. Just want to make you aware of that. It's no difference in the process. So in our case, since we got k, we'll use k. So we got the limit as k goes to infinity, and it's going to be a sub k plus 1, all divided by a sub k. Okay. So let's go ahead and do it here. So we'll have the limit as k goes to infinity. And typically I won't write this step, but I'll write it just particularly for this video, and I'll explain. So what we got is our x or a sub k plus 1. That's what needs to go first in our case. So all we do is we take every place that we see in x and we replace it basically with a k plus 1. So keep that in mind. So this would be x minus 1 all raised to the k plus 1. And we're going to divide all of that by k plus 1 factorial. Okay. Then we divide that by our a sub k. So what was our a sub k? Well, our a sub k was x minus 1 all raised to the k, all divided by k factorial. Now typically I won't write that step, but what you need to know is that dividing by a sub k in this case is the same thing as multiplying by the reciprocal of a sub k. So essentially we can just write this as the limit as k goes to infinity, and it'd be absolute value. And what we'll have is x minus 1 all raised to the k plus 1, all divided by k plus 1 factorial. And then we'll just multiply that by the reciprocal here. So that means that'll be k factorial all over x minus 1 raised to the k. So hopefully that makes sense. So I'll leave the simplification to you. Clearly, the only thing really to do here is cancel these factorials. And so if I end up doing some simplifying, again, I'm going to leave that part to y'all. That part is pretty straightforward. Hopefully you'll end up getting with me the limit as k goes to infinity. And it looks like we'll have the absolute value of x minus 1 all over k plus 1. Now, since we're taking the limit as k goes to infinity, I can take out that x minus 1, but I need to keep it in absolute value. So what I'm going to do is I'm going to pull it out. So I have absolute value of x minus 1. Make sure you bring out the absolute value. You can't drop the absolute value there. You need to have the absolute value over that x minus 1 that you pulled out, because we're taking the limit as k goes to infinity in our case. So we got the limit as k goes to infinity. Now in our case, we can go ahead and drop the absolute value and write it as 1 over k plus 1. Because k is positive as it goes to infinity. So we just take the limit here and we see what we get. So in this case, we're just going to simply get 1 over infinity, which is simply 0 when we take our limit. And why is that? Well, when we take the limit as k goes to infinity for 1 over k plus 1, well, the limit as k goes to infinity 1 is 1. The limit as k goes to infinity with k plus 1, that's just infinity. So this would be 1 over infinity, and 1 over some really large number is going to get closer to 0, so therefore we get 0 there. And so since we end up getting 0, we finish this off here. After applying the ratio test here. Okay, so we just finished this off. And so what we have is L is equal to the absolute value of x minus 1 multiplied by 0, which is what we got when we took the limit as k went to infinity. And we'll set that equal to 0. And so here we can clearly see that the limit is actually going to end up being less than 1. And since the limit will be less than 1 by the ratio test, that means that the power series will converge for all x. So it will converge for all x. And so remember, in the case where that happens, where the series converges for all x is equal to c, then we basically say that the series has an infinite radius of convergence. So in our case, since we ended up getting L is equal to less than 1, we can say that the radius of convergence is going to be infinity, because the power series will converge for all x. So our final answer for this is infinity. So our radius of convergence is simply infinity. So I write that down here. So our radius of convergence here is infinity. That's your answer. So I'll post another video, perhaps maybe tomorrow, or maybe today, the day after that, maybe, because I do want to cover some other stuff. I'll post another video of doing radius of convergence and even the interval of convergence. Maybe I'll do another one where we do both radius and interval of convergence. Which basically, when we get to that part, we just check our endpoints and things like that. But I'll try to post another video on how to do this. So this is basically going to be our answer here. And if you have any questions about how I arrived at my answer, let me know. We can talk about it. But I'll see y'all next time.